Hello and Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izzuddin bin Ibrahim. My nomometric is AA190005. My teammate is Amir Irfan bin Ghaffar. His nomometric is AA190457. Okay, this video is for uh, laboratory for industrial electronic lab 3, and this circuit is for activity number 1. Okay, here we can see for the circuit number 1. The circuit number 1 use single acting cylinder and compressor air supply and 3 two-way valve with push button. For the circuit number 2, use single acting cylinder with spring, and this is 3 two-way valve with push button and this air supply compressor. Okay, for the circuit number 3, air supply compressor is a 5 two-way valve with selection switch and this double acting cylinder. Okay, here can we see the component we use and the designation and this description. Okay, we do the simulation and you can see for the circuit number 1, we can see the air flow and flow into the valve and to the piston. The piston is not spring and not do anything. And then we push the push button at the valve. We can see the valve block the air to flow into this cylinder. Okay, for the circuit number 2, here we can see the air is blocked when we push the push button. The air flow can flow into the valve from port 1 to port 2 into the cylinder and push the piston. We release the push button and you can see the spring function to return the piston to original condition and the air will block at valve to flow at valve. Okay, for the circuit number 3, you can see the air can flow from 1 to 4 port into the cylinder and push the piston, and then we push back the push button. Here we can see the air flowing 1 to 2 port and to the retract cylinder port and push the piston into the origin condition. Okay, for the observation number 2, the difference between this valve push button with this valve push button is this push button is momentary. It cannot push button cannot hold itself. It needs physical contact to hold it. After release the push button, it will return to original position. For H3 actuator valve is more like a switch, which is when push the push button, it will hold itself with no physical contact. To return the origin position, we need to push the push button back. A3 is lagging and A2 is momentary push button. Okay, for the question number 1, the function of spring for component A1, A2, A3, B1 and B2 is to return to origin position. Also, spring return work by having a supply of air or liquid on only one side of the piston. When the metal fills the piston, the valve open and close. Then when the supply is cut off, the spring mechanism remove the media and reverse the valve position. Question number 2 for activity 1. B3 does not need a spring because in the circuit have 5-way valve with selection switch. Its component is like switch. First operation is to move the piston to do the operation. For the second is return to the normal condition. When we push the push button, the air from the air compressor supply will flow into the valve 1 to 4 line and go push the piston at the actuator cylinder. Then when we push the push button again, the air will flow into the valve from 1 to 2 line and push the push button back. We push back the piston to the original position. We see V3 also is double acting cylinder which have port to extend and to retract. Okay, that's all. Thank you.
Hello, hi, and assalamualaikum. So my name is Amir Irfan bin Ghaffar. So thank you to Madam B. Okay, so today I'm going to explain about the operation of the circuit pneumatic system for the lab activity 2. Okay, so firstly we need to run the simulation, and then this pneumatic system main power is the compressed air. When we actuated the solenoid valve position to the right side, the pressure air flowing from the port 1 to the port 4 by through the B1. Then the normally closed spring loaded valve will stay in the original position. When the air pressure flowing through B1 with 10% resistance, 10% resistance, this restriction makes the piston cylinder move to the right side, from the left to the right side with the lower speed. The air pressure from this side of the cylinder will flow through B2, but it will be obstructed because the air pressure from the piston cylinder make the ball in the lock condition. The slow movement of the cylinder piston caused by this B1 and B2, but it will be obstructed because the air pressure from the piston cylinder makes the ball in the lock condition. Has adjusted the slow movement of the cylinder piston caused by this B1 and B2 has adjusted to 10% and caused the air pressure will accumulate at this subway. This 10% pressure at subway. The other condition is when we actuated the solenoid position to the left side, and the air pressure will flow from the port 1 to the port 2 through the B2. But in this condition, the normally closed spring load ball will open because because of the high pressure. That make it possible for air to move through it. The piston cylinder will move from the right to the left side with faster speed rather than it move from the right side. This circuit is called flow control pneumatic system because the air pressure controlled by the one-way flow control valve with B1 and B2.
For activity number 2, observation number 1, discuss the effects of setting B1 and B2 equal 10% to the operation of the pneumatic system versus when they are set to 100%. B1 is 100%, B2 also 100%. And see what will happen when the simulation. We push the push button. Here can we see the piston motion is moving fastly. And then we set 10% B1 and B2 10%. We push the push button. The motion of piston is moving slowly. See again. The motion of moving piston is slowly. That is different between when we set 100% and 10%. Lab 3, activity number 2, question 1. Discuss the function of this component below at B1 and at B2. Note that the direction of both is opposite to each other. Okay, the component is one-way flow control valve. Flow control of one-way flow control valve regulate the piston speed of pneumatic drivers during the advance and return strokes. This is done through suitable restriction of the flow rate of compressed air in exhaust air or supply air direction. You can see B1 is direction is up and B2 is direction is down. Okay.
Okay, next I will explain the operation of the lab activity 3. Firstly, we need to run the simulation. Okay, as we can see, the compressed air supply flow in the air to valve A1, A2, and A3, and also going to the C. Then we need to press both A1 and A2 to make the B function. Okay, we look. When we push, I push the A1, but we need to push this A1 and A2 together. Okay, I push the A1 and A2, and then the air can be through to the C. The valve C will be active. Okay, and the cylinder expand quickly. And lastly, if we need to retract the cylinder, we just need to press the A3 valve to do it. Okay. And then the push button will be retract again for the cylinder. This logic function is called the AND logic. Okay, next, for the observation for lab activity 3, describe how to active the actuator below. Okay, so if we look here, to active the actuator, we need to press the push button A1 and also the push button A2. Okay, we look A1 and A2. After equation, the compressed air will flow through input the A1 and also A2 to the true pressure valve. The pressure valve will operate when the two input A1 and A2 are provided into it. If there is only one input, whether from A1 or A2, so it will not produce any output at the point of 2. That's because this is the AND logic gate. So it will not provide any output at the point 2 of the two pressure valve. After that, input A1 and input A2 are necessary to produce the output at point of 2 of the two pressure valve, and from there it will go to the 5 two-way impulse valve and operate. Now the compressed air will be from port 1 to port 4. From port 1 to port 4, that enter the double acting cylinder and also the piston will move forward to the direction. Lastly, the exhausted will be formed from port 2 to port 3. This one. Okay, that's all. Okay, for the next is for the question for lab activity 3. We look here. Okay, we have number 1, show the component used for the logic function in the circuit. Okay, if you look in the circuit, this is the component that used for the function of the logic in the circuit. Okay, the true pressure valve B, the three-way valve with the push button A1 and A2. Okay, for the question number 2, state the logic function. State the logic function implemented, is it or and no or none. The digital logic function is the AND logic. Okay, for the question number 3, explain why C does not need a spring. Okay, the C is does not need a spring is because the actuator C does not need a spring because it has an air pressure that be used to change the normal position. And also, this actuator does not require an air signal to active. Beside that, the air pressure from reverse direction is used to make the valve back to its normal position. Okay, that's all from us, from Amir Irfan and also Izudin. Okay, thank you for watching. See you next time.